I've called this module Preventing Abnormal Termination. Now let me explain what I mean by that. Most of you will probably be aware that it is possible to kill a process. In other words, you just use the kill program and specify the process ID, and what happens is the program dies. Well, it usually dies. It doesn't always die, and I guess in this module I'll be explaining why it doesn't always die. I'll actually give you the knowledge to design your program in such a way that you can do anything you want if someone tries to kill you. First we have to understand what actually it is to kill a process, what it means. Well, what actually happens is when a process is killed, that process is simply sent a signal. A signal is also often known as a software interrupt. And then what happens is, if that process is not designed to handle that signal, and most processes are not designed to handle signals, then that process simply terminates. But it is, as I just mentioned, possible to handle any signal if you simply know how, and that's what I'm going to show you in this module. So any program, which of course includes any shell script, can be designed to handle signals and do meaningful things with them. So why might you want to handle a signal? Well, I can think of three possible reasons for wanting to handle a signal. The first is to prevent the program from terminating. In other words, you may not want to terminate the program upon receipt of a particular signal. It may be vitally important that your program keep running, and so you would of course want to make sure that all signals that could possibly be sent to your program are essentially ignored. Secondly, you may actually be quite comfortable with the program terminating, but you don't simply want to abort the program. You may have a collection of temporary files that are open and being used. You may have even connected to a database or something and need to disconnect from that using a particular command. In other words, just restoring the system to a known good state. So what you would do then is when you receive the signal, you would initiate the process of cleaning up all your temporary files, logging off the database, or doing whatever it is that you need to do to get the system back into a good state, and then deliberately and purposefully exiting yourself. And the third reason is you may actually just want to perform some custom action upon the receipt of a particular signal. There are many signals that a process can receive, many different types of signals, and you may actually want to take advantage of that and say, okay, whenever I receive this signal, it means I'm supposed to do this particular action, which means of course that you can then use signals as a form of inter-process communication, which means you might have a shell script that's running. It might have been running for a while and you want it to do a particular action, and so you can do that from any terminal on the system. You can simply send that particular shell script a particular signal, and that shell script will perform the custom action that has been designed to do when it receives that signal. So essentially you can communicate with that running shell script from anywhere, which is very handy to be able to do that when you think about it. So I need to mention all the different types of signals that are available. I'm not going to go through all of them because there's a great deal of them and they actually vary from one Unix to the next. There's typically over 20 of them, and most of them you'll never see ever in the course of your programming life, but there are a few that do occur reasonably often, and I'll tell you what they are and when they typically come up. The first is signal number 1, which is what we call the SIG-HUP signal, which HUP is short for hang up, and that occurs whenever the user's terminal is disconnected or the login shell is terminated. And that can happen when the modem hangs up that you're connected to, or a telnet session's interrupted, or a network goes down, or your terminal becomes unplugged, or whatever. So what happens then is that every process that's running in your process group, in other words, every process that has been started by your login shell, will receive a hang-up signal. And what they will typically do is simply exit. It's like, well, the terminal's been disconnected, so there's really no point in keeping this program running, so they exit. The second signal is signal number 2, SIG-INT, and the INT is short for interrupt, which occurs whenever the user presses the interrupt key on the keyboard. And the interrupt key is usually set to Control-C, although it can be set to anything that you desire. Now we like to take advantage of that. If we've got a program that we've just started on the command line and we decide that we need to abort it, then we can just type in Control-C and it usually just exits and goes away. The program, of course, can be designed to not do that, to not exit when you press Control-C, and I'll show you how to do that in a moment. The third signal is signal number 3, called SIG-QUIT, and it's just like the interrupt key. There's actually another key on the keyboard that does a very similar thing. It's the Control / key. So those are 3 of the most common ones. There's also another extremely common one, which is signal 15, the SIG-TERM. Now that actually happens when Unix shuts down. When Unix shuts down, it actually sends a signal 15 to every single process that's running on the system, and that is their little notification that the system is shutting down. And what they will typically do is just exit at that point, either by handling the signal and choosing to exit, or just by not handling the signal and being killed anyway. Or if you type in kill and then the process ID on a command line, using the actual kill program, it does actually send signal number 15. So those are the common ones, and those are when they occur. There's actually a couple more, SIG user 1 and SIG user 2, which have been specifically set aside for programmers to use to enable inter-process communication, just like I talked about before, to perform some custom action. Now these tend to vary from Unix to Unix, and on the Linux system that I'm using they are SIG user 1 and SIG user 2 are 10 and 12 respectively. Now just a couple of things to keep in mind. Firstly, it's actually possible to send any signal to a process using the kill program. For example, I could send signal 10 to process 1, 2, 3, 4, 5 just by doing a kill -10. So you can actually simulate various sorts of system events. For example, you could simulate your terminal being disconnected by sending a kill -1 to the particular process that you were involved with. And the second thing you need to notice is that it's actually not possible for any process, any shell script or any other program to handle SIG-9, which is what we call the kill signal. So if you send a -9 signal to any process, kill -9, then that process is almost guaranteed to die. I say guaranteed because there's absolutely no way that it can say, no, I choose not to die upon receipt of signal 9. So now we get to the point where I actually tell you how to handle these signals. And here it is. We use the trap command, which is it's an actual shell built-in command. You typically put it at the beginning of the script rather than halfway through or anything like that, because the handling of the signal will not take effect until the trap command has been run, and it looks like this. You specify as the first parameter the command that should be run upon receipt of the signal that you specify, and then you specify the signal or signals. You can actually specify several signals on the one trap command line, and the same command that you specify will be run upon receipt of any of those signals. So let's have a look at what I'm talking about. I'll give you an example of that. This is something a bit silly, but it's actually very simple. We're going to run the ls program upon receipt of either signal 1 or signal 2. So that's pretty much all there is to it. You put that line at the beginning of the script, and any time a signal 1 or signal 2 arrives at the script, the ls program will be simply run, and then the script will resume its processing that it was doing. So it could be in the middle of doing something else, it could be in the middle of a read, it could be in the middle of anything, and it will run the ls program. And then it will resume whatever it was doing. It will move on to the next line in the script, wherever it was just at when the signal arrived. If you actually want to ignore the signals, then you just use double quotes just by themselves. In other words, the empty command or the empty string becomes your command. So it would be trap and then a pair of double quotes by themselves and then the signal numbers. The command that you specify can even be the name of a function, and it's also possible to specify parameters to either that function or any other command that you want to run when you receive the signal. And here's an example of that. We might have a little function called graceful exit, which could clean up all the temp files, log off the database, or do whatever it is that you need to do, and then exit. So the last line on the example that you can see in front of you is that whenever I receive a signal 1, 2, or 15, I actually want to call graceful exit with a parameter of 2, and that 2 is going to be used by Graceful Exit as its exit status. So if you need to actually provide parameters to your command, you actually have to put the whole command inside double quotes. So I'll show you an example of all this in action. Here is a script I've called test.sig, and as you can see, it just echoes a bunch of lines out to the screen and then sleeps for 1 second between each one. That should hopefully give me about 10 seconds to get a kill in process when I actually start the script. And if I receive a signal 1 or a signal 2, then I run an ls-c. So what I'd like to see happen is this is line 1 appear on the screen, then a second later this is line 2, then a second later this is line 3, and while they're all happening there, I'm going to be trying to kill the process. So I'll take a note of the process ID and then I'll kill it with a signal 1 or 2, at which point the ls should get output to the screen, and then it should just simply continue on with the next echo that it was going to do anyway. That will hopefully prove to you that processing resumes where it left off when the signal arrived. So let's test it and see if it works. I'll quit out. Now what I'm going to do is I'm going to run test.sig asynchronously on the command line, so I've got a chance to type in a kill, and I'll have a grand total of 10 seconds to find the process ID, type it in, and see if it works. So let's do that now. Okay, the process ID is 10607, and there is the output of the ls, and as you can see, this is line 7, this is line 8, this is line 9, this is line 10, also appear immediately afterwards. So if you follow it down, you can see this is line 1, this is line 2. It all gets a bit mixed up there because I'm trying to type at the same time, and that typing comes out on the screen as well. This is line 3, 4, 5, 6, and then somewhere in between 6 and 7 I actually get the output of the ls program, chap 1, chap 2, chap 5, chap 7, chap 9, and so on. And then I get, of course, the rest of the echo, 7, 8, 9, and 10. So I hope that proves that it's working, and that's all I really need to say about trapping. Let's now do the final course exercises for this course.